Hi everyone and welcome back to the channel. In the previous episode we finished implementing the state machine for our Sly Cooper game. Today we are going to implement the pipe climbing mechanic. Before we begin, I just want to let you know that if you would like to follow along and build this project together with me, you can find a link to my GitHub in the channel description. There you will be able to download the full Sly model with animations that I'm using in this project. By the way, if you're interested in 3D modeling, I encourage you to check out my previous series where I show the full process of creating Sly in low poly style. Okay, let's start by adding a new scene for the climbing pipe. Create a new scene with Node 3D as a root and rename it to pipe. Add a mesh instance 3D which will serve as the model of our pipe. Next, add a static body 3D and a collision shape 3D to give the pipe collision. Finally, add area 3D with another collision shape to create the detection zone for the player. Area 3D is a node that detects when other physical bodies, like for example player, enter or exit a defined region. It doesn't block movement like a static body, instead it works as a trigger or sensor. We'll use this to check if the player is close enough to interact with the pipe. Now let's add a new script to the root node and give it class name pipe climbing. In the player script we'll add a new variable called nearbyPipe which is set to the null by default. Back in the pipe script and declare a few variables, a reference to the area 3D, the climbing height and the base offset. We will also keep reference to the player as well as the minimum and maximum climbing heights. Inside the ready function, we'll calculate the maximum and minimum variables. Next, we add signals that listen for when the player enters or exits the area 3D. When the player enters, we store the player reference and assign the pipe to the player's nearby pipe. When the player exits, we clear these references. With the pipe script ready, let's move on the player. We'll add a new state called climbpipe. At the top of the script, let's define some constants. The speed of the climbing, the radius of the pipe, half the player's width, and how long the alignment animation should last. We will also add some variables. The current pipe the player interacts with, alignment timer, start position, target position used for alignment movement, and a flag to check if alignment is in process. In the enter function, we assign the pipe from the player reference. If the pipe is null, we switch back to the idle state. We will also create an exit function to clear the pipe reference. Next, let's add a function to start the climbing animation and call it inside enter. We'll also add another function to pause the animation if needed. To stop the player immediately, we'll set their velocity to 0. Now, let's add the align2pipe function. First, we get the global position of the pipe. Next, let's add a function that calculates the vector from the pipe to the player. Inside, we take the player's position and subtract the pipe position, which gives us the direction vector. Then, we set the y component to 0, because we only care about the xz plane. This way, the vector shows only the direction on the ground, ignoring height differences. Finally, we normalize the vector, which means we don't care about the distance, only the direction. Next, let's add a function to rotate the player toward the pipe. Inside this function, we use a10to, which returns the angel need to rotate an object toward the given vector. We use minus direction from pipe because we want the player to face the pipe, not away from it. Then we assign the rotation to the player's model. Now let's add a function to calculate the player's target position near to the pipe. First, we calculate offset distance by adding the pipe radius and half of the player's width. This tells us how far from the center of the pipe the player should be. Then we multiply direction from pipe with offset distance to offset the pipe center towards the player direction. By adding this to pipe position, we get the target position right next to the pipe. After that, we override the y value with the player's current height so it stays consistent. Finally, the function returns the calculated target position. Back in align to pipe, we store the player's current position, reset the timer and set is aligning to true. Now let's implement the attaching and climbing mechanics. Inside process, we check if the player is currently aligning. If so, we call the process alignment function. Inside process alignment, we calculate the elapsed alignment time. Then we compute the interpolation factor and smoothly move the player from the start position to the target position. Let's explain what interpolation is. Interpolation means smoothly transitioning between two values. Instead of instantly jump from point A to point B, interpolation calculates the in-between values based on time or a factor. In our case, we take the player's starting position, we take the player's position near to pipe, and we want the player to smoothly move there within a set duration. The interpolation factor is a number between 0 and 1 that tells us how far we are moved from the A to B. Now let's add jump detection. If the player jumps while climbing, they detached from the pipe. Next, we'll implement the climbing system. We start by adding a function called getClimbInput, where we check which direction the player is climbing. Based on that, we play the climbing animation or pause it. Then we add a function called movePlayerAlongPipe, which moves the player up and down the pipe. First, we calculate the player's new Y position. Then we clamp the movement so the player can't go beyond the pipe's top or bottom. Finally, we update the player's position. At the end, we'll move to the jump state and add check for the interaction button. If pressed, the player transitions into climbing state. Now, let's add pipe to the main scene and run the project. Okay, in this episode we implemented climbing system for our Sly Cooper game. If you enjoyed this episode, don't forget to leave a like, comment and subscribe. It really helps me to stay motivated to keep making more content. Thanks for watching and see you in the next one.